In lesson 8.6, you looked at quadratic function graphs. And in this lesson, you're going to be continuing to think about quadratic function graphs, but you're going to learn how to find the vertex and the intercepts without actually graphing the quadratic function. The first thing we're going to talk about is converting quadratic equation to vertex form. So you probably recognize the vertex form from lesson 8.6. The cool thing about vertex form is that you can automatically see what the vertex of your quadratic function is. So remember, the vertex is that point right there in a quadratic function graph. And here you can see that you already know h and k directly from this equation. So you can quickly determine the vertex. The quadratic equation is really useful for finding the intercepts, x and y intercepts. And we're going to look at that for a little bit more at the end of this lesson. But first we need to be able to go from quadratic form to vertex form. So let's look at that. There are 3 steps to move from the quadratic equation form to vertex form. So your first step is going to be to rewrite the quadratic equation using this red equation here. So the normal form of the equation is fx equals ax squared plus bx plus c. And so you're going to rewrite that with ax squared and bx, these first 2 terms, inside parentheses. And then our third term is going to be outside of those parentheses. And then you're going to add a blank and subtract a blank. If we add a value and subtract that same value, we get 0. So let's just imagine these were 2 and 2. If you add 2 and you subtract 2, then you're really just adding 0. So we can always do that to an equation on one side of the equal sign. If we're adding and subtracting the same thing, it's just like adding 0. But by doing this, we're going to be able to put the equation in vertex form. This note right here is really important. If a is not equal to 1. We're going to look at an example where a is equal to 1, and also an example where a is not equal to 1. When a does not equal 1, we'll have an extra kind of half step that we have to consider. The second step is going to be to fill in the blanks using the same method as completing the square. So we learned completing the square many lessons ago. And what we plugged into the blank when we were completing the square was b divided by 2 squared. And that's the same thing we're going to use to fill in these blanks here. Okay, we use completing the square in order to create a perfect square trinomial, which we learned about in a previous unit. Okay, that's what we're going to create here. And if we do that, if we have a perfect square trinomial, we're able to write a binomial squared. So remember, that's that a plus b squared. And then we'll have our perfect square trinomial plus another term. That term is going to be figured out by combining the like terms outside of the parentheses. So basically by adding these together or subtracting, this is going to be our k value in vertex form. So let's look at an actual example, and we'll follow these 3 steps in the example, and it will become a lot more clear. Basically, step 3 is writing our equation in vertex form. This just explains how to do that. All right, so here's our first example. We're going to define our variables after we rewrite this equation. Okay, so we're going to rewrite fx equals, and then remember, in parentheses, we're going to put the ax squared term and the bx term. So we're going to write x squared minus 2x, and then we're going to have that blank. So if we look back here, ax squared plus bx plus our blank. On the outside, we're going to write our c term plus 3, and we're going to subtract the blank. In this equation, a does equal 1, right here. So we don't have to worry about factoring anything out. We've got b, which is minus 2, and we've got our c term, which is 3. Step 2 is to figure out what to put in these blanks. What value are we going to plug in here? Remember, like completing the square, it's b divided by 2 squared. We've defined our b value up here as negative 2. So we can rewrite this as negative 2 divided by 2 squared. So you just plug in b. This simplifies to negative 1 squared. Negative 1 times negative 1 is positive 1. Alright, so this is the value that we can now plug in to these two equations. So step 2, figure out what goes in those blanks. So that value is 1. And then our third step is to write this in vertex form by writing this perfect square trinomial in binomial squared form. Okay, so that means that we're going to rewrite this as fx equals x minus 1 squared. And that comes from the rule that we learned in a previous unit. Okay, for a perfect square trinomial, we take the two values here and square them, or take the square root of them, sorry, to get our values for a and b. Basically, what you really need to know is that this value will match the square root of this value. Okay, so in this case, the square root of 1 is 1. And then you're going to combine like terms to get our plus value over here. 3 minus 1 equals 2, so we've got plus 2 over here. And we've successfully written this equation in vertex form. Okay, so the directions said write in vertex form. We have successfully done that. Now you can see you can very easily find the vertex of this quadratic equation because it's in vertex form. So the vertex here is 1, 2. Okay, that's just extra information. It was not asked of us in this example directions. But you can figure it out pretty quickly, which is the point of writing our equation in vertex form. All right, let's look at a more complicated example where a does not equal 1. Your first step is still going to be to rewrite this problem, or this equation. Okay, so we're going to put ax squared and bx inside plus a blank, and then c outside minus a blank. Now we've got to do that kind of half in between step because we have an a value that is not 1. So that means we have to factor the 2 out. To factor 2 out, remember factoring, we divide by 2, or we divide by the value we're trying to factor out. So that means we're going to divide both of these terms by 2. So we get fx equals 2's factored out. 2 divided by 2 is 1, so we get x squared. 12 divided by 2 is 6. And then we still got plus blank, and out here we get plus 16 minus blank. This blank is going to be a little bit different now because of this 2, and you'll see that in 1 second. All right, so we're going to actually use this value for b, not this value up here. That's because we want this right here to be a perfect square trinomial. So that means that b equals 6 in this case. So for step 2, you're going to take b divided by 2 squared to figure out what to fill in the blank. B is 6, so we have 6 divided by 2 squared equals 3 squared equals 9. So that's the value that we're going to plug in right here, 9. However, the value that goes on the outside of these parentheses has to take into consideration this 2. So it's going to be 2 times 9. That's what's going to go in this blank. Okay, so you're going to do this value outside of the parentheses times this value inside the parentheses to get our new value. So 2 times 9 is 18. Now we're going to do the same thing as before. We're going to factor this using our rules for perfect square trinomial, which means that this is going to be the square root of 9 is 3. So we get step 3, we get fx equals, the 2 remains on the outside of the parentheses. Inside the parentheses, the binomial of this perfect square trinomial is x plus 3. Remember, we get this value by taking the square root of this value squared. And then combine like terms, 16 minus 18 is negative 2. So that's going to be our value outside of the parentheses. And here we have our equation rewritten in vertex form. Again, you can really quickly find the vertex here. -3, -2.